Welcome to part 2 of the presentation of Rothman's additive interaction. This is the table that we left off on, and it's important to fill this table in. You need to know what is your exposure, what is your effect modifier, and what is your outcome. You have 2x2 tables that I've given, and I'm just going to use one of those examples, specifically using the example of male and female, using female gender as the effect modifier. So this is a visual representation of effect modification. In this example, we're going to look at the outcome of reporting having always felt blue in the past month. And this is the final follow-up time point of 2015. The initial data was taken from 1997. Adolescents were asked whether or not they had been bullied before the age of 12. And we're going to look at that exposure in relation to being females and effect modifiers. So if you look at the pie on the left side, the exposure is being bullied before the age of 12. The effect modifier is being female. So we're going to fill in the table using that data. And on the upper right is the table. It's a stratified table with male results and female results given separately. And remember that our effect modifier is female. So when we're looking at effect modifier is yes, that's the lower variable. We're going to look in the female set. And then when we're looking at the exposure is yes, we're looking in the bullied group. So the first thing that you'll put on this table is your exposure and your effect modifier yes, yes condition. Look to those rows and fill in the number for A1 as 18. It's going to be the same placeholder as what it is in the table that you see in the PowerPoint slide. And then your B1 is going to be 582. So you have the yes, always blue, that's your outcome, and your not always blue is your no condition. So for each of these parts of the table, we're going to go through the process of taking these stratified 2x2 tables and splitting them up in relation to whether or not the person has the exposure and the effect modifier. And then you just simply, once you find the right row, you report their outcome yes, outcome no, in the same order as it's given. So in the next slide, we're looking for the effect modifier is no, so that's the males. And we're looking for the males who were exposed, the bullied group. So there you have, in the next row, 10 and then 761 to fill in. In your third row, you're looking for those who have the effect modifier, so females, but who don't have the exposure, so they're not bullied. And so your A3 group is going to be 35, and then the B3 is going to be 2,804. So when you're filling this in with a different variable using a different 2x2 stratified table, remember to look effect modifier yes or no, and then once you're in the right group is the exposure yes or no, and then fill in the details. The final group, which is going to be the comparison for all of your analysis, is the male not bullied group. So this is the condition of neither having the exposure nor the effect modifier. So just keep in mind that our reference group is males who are not bullied. And that's the concept of the group that reflects the unknown factors. So their reporting being always blue in the past month has nothing to do with being female or having been bullied. Now, this is filling in the data as I showed earlier, but specifically looking at the comparison between the risk ratio of both together as compared to neither. So this is filling in the 18. And here the N1 is adding up the A1 and the B1 conditions. So this is giving us our risk of both together divided by the risk of neither. So look at that carefully. Look at the calculation. Remember how risk ratios are calculated. So that's the 18 divided by 600 over the 25 divided by 2,579. And the answer there is 3.09. So if you compare those who were both bullied and female to those who were not bullied and boys, then their risk ratio is 3 times more likely to report having been always blue in the past month. In terms of excess risk, we subtract out that underlying 1, and you get an excess risk of 2.09. So that means we're talking about an excess risk that's related to being female and having been bullied. Now that excess risk, the question is whether that's greater than not just 0, but is it greater than the risks related to just being bullied or the risks related to just being female. So let's find out. So we want to know what is the excess risk related to just being bullied, just the exposure alone. So here we have that table, and I've just taken out the second row related to only the exposure and that fourth row, which is our comparison for all of this analysis, so that we can look at the risk ratio of just the exposed to those who are neither exposed nor have the effect modifier. And so, as I showed earlier, the numbers come from having only the exposure, that's only being bullied. So these are boys who were bullied compared to boys who were not bullied. And we have a risk ratio in that comparison of 1.34 minus the underlying risk. So it's no longer a risk ratio, but an excess risk. And we have an excess risk of 0.34. But what about the excess risk related to being female? Does that explain the gap? And so here we're going to look at the risk of only being female. And for that, we're taking rows 3 and 4. So 4 is that comparison. The boys who were not bullied is always our comparison group. And we're just looking at the girls who were also not bullied. So we're just comparing essentially the non-bullied boys and girls, or girls compared to boys. And we see that just being female compared to male is a risk ratio of 1.27, and excess risk is 0.27. So again, some excess risk, but still quite small. What does this look like if you add it all up? So remember here, this is our table. Now we're going to add a new column to that, and that's the excess risk. So those are the formulas that we've been applying to get the excess risk so far in that column. And we're going to put them all in rows related to the column. So here the excess risk of both together is 2.09, and we're going to compare that to the 0.34 and the 0.27. And we find that 2.09, the excess risk of both together, is much greater than the added risk of just being bullied and just being female. So what does this all mean? And the results we see, female gender appears to modify specifically to amplify the effect of bullying. So if we're looking at our associations, we see the adolescent females who reported in 1997 that they had been bullied before the age of 12. Those girls are 2.4 times more likely to report being always blue 18 years after that initial survey. Now, this is a strong association, and it also happens to be statistically significant. By comparison, in males, the association was much weaker. The relative risk was 1.3, and it was not statistically significant. So the important thing when you're looking at effect modification is by looking at stratified data, you can better understand what is happening in different groups. So if you were to pool the results of males and females, you wouldn't get the whole picture. You wouldn't see that the girls really have a much stronger relationship in terms of whether or not they had been bullied before the age of 12 or how they reported the bullying before the age of 12, and their reporting of being always blue 18 years later.